So this is going to be our introduction into some of the different operands that exist within Python. This, of course, will be focusing on the two ands and, which can get a bit confusing, but what they're doing is really very different. And this is going to get into the area of bitwise operators, which can be a little bit confusing, but we'll go into depth in those in our next video. But this and function, one of our ands, is a bitwise operator, and so it's going to really help you sort of lay a strong foundation for bitwise operations, and hopefully when you come across that next video, it will make everything a little bit easier for you to understand. So with that being said, we're looking at our two ands that you can see over here, right? And in Python. And these two things, as we said, they're doing very different operations. And so we'll start with the easy operation first and get into the one that's a little bit more challenging, but as you'll see, once we break it down, it's very easy what's happening, and like I said, it will help you lay a really strong foundation into how these bitwise operators are working. So starting with the easier of the two, we have our and this and is a logical operator. So what does logical mean, right? When we think logical, we need to think of true or false, right? This is just a true-false operation. So let's say, for example, right, we had an x value and we had a y value. We had two different values. We had an x and a y. And so for the x variable, we could assign, say, we could assign number 9. And for y, we could assign a value of 12. So if we were to call a print statement, right, in Python, we call a print statement, and we say x and y. What is this really asking? What is our and? So our and, as we said, is logical. It's a true or false. And it's important to remember here that the way that this and works is doing something called lazy evaluation. Lazy evaluation. And so why is it called lazy evaluation? Well, it's called that because if our first value is false, then it just stops, right? It will just immediately finish, and it will become false. The whole statement must be false, right? Because and if something is true and something else is true, then we know that the whole statement is true. But the moment that something becomes false, right, the whole thing must be false, because if you in order for a statement to be true, right, everything must be true. But in order for a statement to be false, the moment that one of the operations or one of our values is false, then the whole statement must be false. And so where our lazy evaluation comes in is that if our x value, we check our x value first, is x true? And so we can see right here that yes, x is true because x does have a value. It completes this logical operation of true or false. X is true, it does contain value, so it passes the test. So we move on to the next thing. Now we check our y. Is y true? Yes, y is true, right? So our statements are true, right? So our statement is true. X and y is true. And our output will simply be 12, right? We'll just return our 12, right? And that's it. So again, we're just kind of completing our logical operations. They're true or false statements here. And these statements are pretty easy. What's happening with this and is fairly straightforward, right? So where things can become a little bit more challenging is where we get into the bitwise operations, but as you'll see, it's not as bad as it might seem. So when we look at this and over here, right, this and I'm going to do a terrible job of drawing these ands. So what this and is doing is it's a bitwise operator. So what is a bitwise operator? A bitwise operator means that we're dealing with the binary representation of numbers. Something is happening in the binary. It's not happening in the integer representation of something. So for example, if you had number 3, right, a bitwise operator would be acting on the binary representation of 3, which would just be 0, 0, 1, 1, right? So let's follow the same example, right, using some sort of consistency. Follow the same example we used for our previous and let's define our x and y values again. So if our x is 9 and our y is 12, if we're calling a print statement in Python, because we want to see, okay, if we use the print statement, it's a really good way of seeing like what's happening, right? Let's return a value. So if we're calling x and we're calling our y, hey, that and wasn't too bad. If we're calling x and this bitwise operator on y, what's happening here? Well, the first thing that we're going to do is we're going to get our x's binary representation. What is our x's binary representation? Well, 9 is the equivalent of 1, 0, 0, 1. And what's 12? 12 is 1, 1, 0, 0, right? So how do bitwise operators work? How does this and working? Well, now that we've got a focus here on the binary representation of 9 and 12, all and is doing, just like we saw previously with true and true, in order for a statement to be true, both things must be true. We can see that same and here. We can think of this as 1 and 1, right? 1 and 1. So in this case, with right here, if we were to compare, so you can see right here, we're comparing x and y. So the first step, it's a bitwise operator, convert our numbers into the binary. So here, step 1 is complete, right? Step 1, numbers in binary. Step 2 is compare. Is 1 and 1. What do I mean by 1 and 1? I keep saying 1 and 1, right? What do I mean by that? What I mean by that is 1 here and is 1 here. And if that's the case, then we know that for our output, we will also have a 1 in that position. Now again, let's check the next set of numbers, right? We have a 0 here and we have a 1 here. They are not, both of them are not 1, right? Even though we have a 1 down here, this isn't a 1 right up here, right? So both are not 1, so this must be false, or in this case, 0. Now let's check again. So we have a 0 here and a 0 here. They are not both 1, so it's a 0. And then we'll check on our last number down here. This is a 1, but this is a 0. They are not both 1, so this must be a 0. So when our print statement churns out a number, it's going to churn out, right? It's going to churn out whatever the actual integer representation of this binary number is. So in this instance, right, we would be looking at the number 8. 1, 0, 0, 0 is just 8. So by calling print x and y, our output is 8, right? It's going to be 8 because that is the integer of this binary representation that we're looking at right here. So that's all we're doing. It seems a little bit challenging at first, but once you understand it, all you're doing is making comparisons between the two numbers that you're dealing with in a binary representation. So the computer is going to convert them into binary when you're dealing with these bitwise operators, and it's going to compare with and. Is 1 and 1, right? That's all we're looking for, 1 and 1. Is 1 in both numbers in that position? And if it is, that's going to carry down into our result, right? So you can see here, we have a 1 and we have a 1 in the first position. So now we're going to have a 1 down here in the first position. And that's the reason why we only have number 1 in our result, because the rest of these numbers here, it's not 1 in both positions, right? So that's it. So this is the biggest difference between these two ands. One is a bitwise operator and one is logical. And now that we have a good foundation, a good introduction into how these bitwise operators work, once we encounter those in our next video, things will be a bit easier, right? So thanks so much for watching, and we'll see you in the next video.